All right, on number 20, we have a circle with a diameter of 20 feet and it contains a chord that is 16 feet. So I have drawn a circle. I just need to prove that it's a diameter by showing that it goes to the center. So here's my center. And again, according to, I believe, 10.3 on page 3 of your notes, the diameter will bisect the chord. So that means this half of the chord is congruent to this half, and it's perpendicular to the chord. So if at the intersection I expect a right angle, because again, that's what perpendicular means, folks. So if the diameter, the chord, I'm sorry, is 16 feet, that means each half is 8. So 8 over here and 8 over here. And the entire length of the diameter is 20. So that means each part is 10. Don't forget that. Now, it wants to know the distance from the center of the circle to the chord. So I'll highlight that distance for you. My goodness gracious me. So what you're going to have to do is add another radius or add a radius to this circle. So you're going to draw a radius to the chord, and that radius is going to be 10 because that's half of your diameter, of course. And we're looking for this part anyway as our final answer because that's the distance from the center to the chord. So again, this is a right triangle. So we're going to use Pythagorean's theorem. A squared plus b squared equals c squared. We have c, which is 10, and we have a, which is 8. We're looking for b, which is x, sorry. So 8 squared is 64, plus x squared is equal to 100. So I have to subtract to get x squared by itself. So x squared is going to equal 36. And then I have to take the square root of both sides. So x is equal to 6. So in other words, the distance from the center to the chord is 6 feet. For number 21, it tells us that W is, the measure of W, angle W is 85 degrees. It wants us to find the measure of angle Y. So this is also on page 3. When you have a quadrilateral inside of a circle, the opposite angles are supplementary. Sorry, this is page 4 of your packet. So in other words, the measure of angle W together with the measure of angle Y, because they are across from each other, that's what opposite means, is 180. So if the measure of W is 85, I would need to subtract that from 180 in order to find the measure of angle Y. So when I subtract 85 from 180, the measure of angle Y would be 95. So 95 degrees is the measure of angle y. In a similar manner, x and z are opposite of each other, so they are also supplementary. So the measure of angle x together with the measure of angle z is 180. They give us angle z, so in order to find angle x, again, I would have to subtract the measure of angle z, which is 42, from 180. So the measure of angle x would be 138. 138 degrees. For number 22, it tells us that angle A is 29. It would like for us to find the measure of arc DC. So angle A, it is an intercepted angle, an inscribed angle, and arc DC is the arc that is intercepted by angle A. So if I want to know the measure of arc DC, I would take 2 times the measure of angle A. So that means it's 2 times 29, which means it's equal to 58 degrees. Because if you don't remember that the measure of the angle is equal to half the measure of the arc, but the measure of the arc is equal to 2 times the measure of the angle. But this is for intercepted arcs and inscribed angles only. So now if I'm looking for the measure of angle B, it also intercepts arc BC. Excuse me. So one way of doing it is that angle B is half the measure of arc DC. So that means it's half of 58, which means it equals 29. Another way is to remember theorem from day 3 notes. So it's on page 4 of our packet. And I believe the theorem was 10.8, or sorry, 10.7, which says if two angles intercept the same arc, so angle A intercepts DC, angle B intercepts DC, then angle A is congruent to angle B. So I really didn't need to take half of that arc if I remember that theorem, but if you don't, then there you go. So it tells me that angle D is equal to 3y plus 8, and angle C is equal to 5y minus 14. It wants us to find y. So angle D intercepts arc AB. As you can see, angle D is giving that arc a hug. That's what it means to intercept. They give each other a hug. Angle C is hugging arc AB as well. So I could say that angle D is congruent to angle C, which means the measurements of angle D is equal to the measure of angle C. So you equal them together. So that's 3y plus 8 equal to 5y minus 14. and solve for y. First, subtract 3y. So 8 is equal to 2y minus 14. Then add 14. So 22 is equal to 2y. Divide by 2. Y is equal to 11. And our last question. Number 23. The radian measure of a central angle is the ratio of the arc length to the radius of the circle, which is illustrated by the formula in the box. Radian equals arc length divided by radius, in other words. So in circle A, what is the radian measure of angle BAC? So angle BAC is this angle right here. So we're looking for that measure in radians. So the measure of this angle, BAC, will equal the measure of arc BC. I'm sorry, the measure of the length of arc BC divided by the radius of the circle, which they tell us is AB. All right. So they give us the length of arc BC. They tell us it's 28 feet. They give us the radius AB, which is 20. So you're taking 28 divided by 20. Grab your calculator, carry out the division, and we're done. So 28 divided by 20 is equal to 1.4. So we would say it is 1.4 radians. Sorry with all the interruptions, but this finally concludes our review for the test. Good luck.